Okay, so that quiz, sum and difference identities, if anybody did score below an 80 and you're interested in retaking it, you have until next Friday morning by 8:05, the end of tutorials. I believe that is November 14th, so next week's going to be a normal full week, so you got a lot of opportunities. You do need to turn in the sum and difference identities assignment before the retake, though. Okay, so is there anybody here? No, Caleb, did I get you those notes yesterday? Okay, I don't know if I did or not, because I remember it came in. Okay, so go ahead and get those. Was there anybody else who was absent yesterday? Okay. So we started talking about how to solve trigonometric equations. It's just like what you've done in the past when solving other types of equations, linear, quadratic, rational. You're looking for all the values that are going to make your equation true. Okay, here we're looking for our answers to be angle measures. So if I were to plug those in, we have a true statement. Now, half of the problem, the first half, is isolating your trig function. So right now, we're only looking at some basic equations. Okay? So once you get your trig function isolated, based on the sign of your ratio, this is where you're going to choose what quadrants you're going to start drawing some triangles in. So to help us out, we have this. All students take calculus. So the first letter of each word is a trig function. Well, except for a, all. That's all 6 are positive in the first quadrant. But S in students, that stands for sine, and it's reciprocal. Remember, we've talked before that reciprocals are going to have the same sign. Okay. T for tangent and the reciprocal cotangent. And finally, C for cosine and its reciprocal secant. Now, what's nice about this, if you know in what quadrants the trig function is positive, that means the remaining quadrants, it has to be what? It has to be negative, yes. So we'll be revisiting this for sure. Okay, we went ahead and looked at one graphically. So we're currently on number 3. Now, before we go ahead and get started, I want to address the papers that you picked up on the way in. Yesterday and today, we are just looking at, as I said, basic equations where you can simply isolate the trig function. But starting on Monday, we're going to begin to look at more complicated equations. You're going to have to factor in some parts to go ahead and solve these, and then we're going to start incorporating identities. Now, we haven't really talked about factoring in here a whole lot, and some folks out there might be thinking, ooh, it's been a long time, I'm kind of rusty. So that's why I provided you these sheets here. One of which, this is a factoring map that I've been using for decades. I've used this all the way since my student teaching. It's fantastic. It walks you through step by step how to factor any polynomial you come across. Okay? Gives you all the forms, everything you need. Now, this is what I'm going to use when we're factoring a trinomial. My father drives a red Mercedes convertible. I know it sounds weird. Okay? Here's the thing. If I were to say, please excuse my dear Aunt Sally, what is that used for? PEMDAS, parentheses, exponents, etc. It's a way to help you remember, right? This here is the exact same idea. The first letter of each word is a step in the process. Okay, so I'll be talking more about this next week, but I wanted to kind of give you this as a heads up if you want to take a look at it. Also, if you are kind of rusty on factoring, I gave you this little quick reference sheet. Has everything on one page. Now this one's full. The copy I gave you has the problems, but they're not factored. Okay, so if you're thinking you need a little bit of practice, I've given you some problems to go ahead and do that. I posted this key to our website. Okay, so I just wanted to give you a heads up before the weekend. We're going to start factoring on Monday, but not today. All right, let's get back over here to number 3. So I want to solve cosecant of alpha minus 6 over 4 equals a negative 1. Okay. Now, each one of these is going to give you an interval to solve on. So we'll talk about this infinite interval at the very end of the problem. Okay. Yeah, just like yesterday, treat cosecant as if it were a variable. I want to get it isolated. Okay. What's the first thing you would do in this equation? I'd multiply by 4. I'd go ahead and get rid of that fraction. Okay, so let's do that. So if I distribute, that's going to give me cosecant of alpha minus 6. And then 4 times negative 1, we're looking at negative 4. Now, yesterday, on the first problem, I was showing how I moved terms across the equation. Did anybody want me to continue doing that? What I'm referring to is like in the next step, to move the negative 6 over, I'd have to add it, right? So this is what I'm referring to. I would actually show how that happens. Did anybody want me to do that? Cool. All right, so what should cosecant of alpha equal? Okay, negative 4 plus 6 is 2. Right there, that's half your problem. Okay. When taking these back. First half of the problem, I've got to isolate my trig function. Okay. Questions on that? Just like you're solving an equation. Now, from here, this is when we're going to go to my coordinate plane. Now, we're going to take the sine of this ratio, and you're saying, what ratio? It's just a number. Oh, thank you. Well, you can easily put this over 1. Okay. So think about all students take calculus. Where is cosecant positive? In what 2 quadrants? 2 and 1, yeah. So I'm going to go ahead and draw my triangles in quadrants 1 and 2. Remember, cosecant is the reciprocal of sine, so wherever sine is positive, cosecant is going to be positive as well. One thing about these triangles, no matter how many you happen to draw in one plane, they're all identical. They're all going to be the same. Okay. Well, let's start to fill these in because we've seen this before. What's cosecant's ratio? It's r over y. Okay. So now this gives me 2 side lengths for each of the triangles. I know that each hypotenuse is 2. I know that each of these heights here is 1. Can anybody tell me what the other leg would be? It is the square root of 3. Remember, we're starting off where the majority of these equations are either going to be special right triangles or they're quadrantals. It won't be until later next week that we talk about those that won't be special. Okay. Does anybody want me to do the Pythagorean theorem? Okay. Well, what kind of triangle is this? It's a 30, 60, 90. So these 2 reference angles right here, are they 30 or are they 60? They are 30. Why 30 though instead of 60? The smallest angle has to be across from the shortest side. So we're almost done with this problem. First half was to isolate the trig function. Then using that, we got our correct quadrants, we got our triangles. Any questions so far? Well, does anybody remember how did these triangles get me my answers? What did we do yesterday? Yeah. What do we call that? 2 words? Starts with an S? Standard position. There we go. So what you're going to do is start in standard position. Remember, that's the positive x-axis. You're going to rotate counterclockwise to each hypotenuse. So for this first one, if I start here and rotate counterclockwise, well, the first distance I rotated was 30 degrees. So that tells me that alpha is 30 degrees, but I want the final answer as a radian. So I'm going to say pi over 6. But there's a second triangle, which means a second answer. So I'm going to start in standard position again, and I'm going to rotate to that hypotenuse. How far do I rotate for a reference angle of 30? 150. So that is my second answer. And you might recall that 150 is 5 pi over 6. Okay. So it might not be a bad idea at this point going into these equations. Take a few minutes, look over your unit circle, kind of refamiliarize yourself with the angles, the degrees, and the radians. Okay, now, is this problem done? Why not? I got my answers. Okay, remember at the beginning I said we were going to go ahead and talk about this infinite interval. If they give you this interval, they want every solution that exists. So that means I've got to write these as expressions. So what am I going to add to the end of these? Plus 2 pi n. So we're adding or subtracting multiples of 2 pi. And remember, to identify the variable, where n is an integer. It belongs to the set of integers. Now, let me ask you a question. If I'm given this infinite interval, will I always add 2 pi n? No? Under what circumstances would I add something else? Tangent and cotangent, I'll just add what? Pi n, yes. There we go. We are solving trig equations. Anybody having a hard time? Okay. Well, let's try number 4. Okay. So 7 secant of y equals secant of y minus 4 root 3. Okay, so again, this is an infinite interval. So at the end, I'm going to have to add something to my answers. Okay. So I got to isolate secant. How should I do that? Okay, let's just subtract secant over. So what's a 7 secant minus 1 secant? So that's a 6 secant of y is equal to a negative 4 root 3. Now what? Divide by 6. There we go. Just like I'd isolate a variable, I'm going to isolate a trig function the same way. So I'm getting that secant of y equals, well, the negative 4/6 would simplify to a negative 2 root 3 over 3. Okay. Nobody was still out in the hallway, right? Yeah, I think we're good. Okay. All right, right there, that's half your problem. Half the work's already done. All right. So now, all students take calculus. Okay. Yes, ma'am. Do you have your badge? Okay. Where is secant negative? 2 and 3. Okay, very good. So I'm going to draw triangles in 2 and 3. And this step is crucial here because I've already seen students put the triangles in wrong quadrants. That's odd. You might get the right triangle, but in the wrong quadrant, it's going to give you the wrong answer. Okay. So is everybody okay while we're in 2 and 3? Okay. Well, secant's ratio is going to be a radius over x. Here's the thing, though. The way I wrote this fraction, it looks like the radius is negative. The radius is always positive. Okay. So each of these here, I'm going to go ahead and say 2 square root of 3, 2 square root of 3. That means the x, this shared side right here, that would have to have the negative. And that makes sense because we're left of the origin. Okay. So what's the missing side? Anybody? Not negative 3. Not 3. You got to do something to 3. What's that? Square root of 3. And this one would be negative because it's in the third quadrant. You might want me to run through Pythagorean theorem on that one? Yeah, let's do it. Okay. So let's see here. So let's say that this is A, this is B, and this is C. A squared plus B squared equals C squared. So let's say we don't initially know that. So A squared plus B squared, so a negative 3 squared, equals C squared, 2 square root of 3 squared. So that's A squared plus 9 equals, what is a 2 root 3 squared? That's 12. Okay, 4 times 3. Now I'm going to subtract the 9. So A squared would equal 3. And see, that's where I get my square root. Okay. So these are 30, 60, 90s. Okay. These reference angles here, they'd have to be 30. because the square root of 3 is smaller than 3. Remember, the smallest angle has to be across from the shortest leg, shortest side. All right, so any questions about how I labeled my triangles? Okay, how do I get my answers? Standard position, and then we what? Rotate. Okay, so let's see here. If I start here and rotate over, well, we just saw this one a moment ago, 150 degrees. That's my first answer. So I'm going to go ahead and say 5 pi over 6. Remember, our final answers we want is radians. Okay, bless you. Now I'm going to start in standard position again, and I'm going to rotate around to the other hypotenuse. What's a 180 plus 30? 210. That's my second solution. And you might remember that 210 is 7 pi over 6. Okay. And what do I have to do? There you go. It wanted the infinite interval, so I have to add 2 pi n to each of these. Remember, you'll only add pi n if it's tangent or cotangent. All right. Anybody having a hard time? You're probably thinking, man, this is way too easy. I could show my friends how to do this. Okay. So number 5, I'm going to give you 2 minutes to work through this problem, just like we have been. And then we're going to have a couple folks come up and walk us through this. Okay. So 3 tangent of A equals tangent of A minus 2. Okay, let's see here. So in this class, we got to go to 29. Bless you. Bless you. Okay, so we got that a good shuffle. We are down to 40 seconds. I heard that. It's going to be based on a coin flip. Because what Amarillo was playing ineligible players or something? Yeah. Wow. So, man, fingers crossed. Yeah. There you go. And hopefully Amarillo learned a valuable lesson. All right. Here we go. Oh. Okay, Sophia. Okay, so I said 2 people were going to come up here. So, Sophia, all you have to do is solve this for tangent. Once you have tangent of A equals, then we'll spin again. We'll get somebody to draw the triangles. Okay, so we're going to subtract tangent of A. So 2 tangent of A equals -2. We divide through by 2. Tangent of A equals -1. Perfect. Just like that. Okay. Now I'm going to go ahead and put this over 1. Let's spin it again. who is going to help us with the last part. Mariana, but isn't she in the restroom? Oh, she's going to be so disappointed when she comes back. What's that, Kagan? You said you wanted to volunteer? What? Oh, oh, wow. Okay, I'll tell you what. They really want Mariana to come up. Let's spin it one more time. I know, that's crazy. There we go. May! Oh, that's probably Mariana, too. Oh, but we already spun again, so May. Sure. All right, so May. We need to decide what quadrants we're putting our triangles in and use those to get our solutions. Okay, so where is tangent negative? Second and fourth, perfect. Okay. So everybody's okay, why is she choosing 2 and 4? Okay. So we know each leg is how long? 1, there we go. And then those will change depending on, the orientation. Goes right to it. So what kind of triangles are these? 45, 45s. Okay. So if this right here is 45 degrees, how far did we just rotate? 135. But what is that as a radian? 3 pi over 2? Close. 3 pi over 4. So A equals 3 pi over 4. Okay. And then now let's rotate around to the other hypotenuse. Oh, now we want to rotate counterclockwise because we want to be on the interval from 0 to 2 pi. Even though that would still work, it would be a solution. Okay. So we rotate all the way around. So if this right here is 45 also, how far did you rotate? 315, which is? Seven pi over 4. That's it. Okay. Oh, actually, we don't need to do that. I'm glad you did that, though. Okay. Why on this one do we not need to add anything? There you go. It's not the infinite interval. It just wanted the exact solutions on one revolution. So if you were to put that on like a quiz or test, I'm not going to count off. But this time, all you need is that. Perfect. Questions? How we doing? All right. Okay, well, let me go ahead and erase this very quickly. And then it is time for our SEL. I'm excited about this.